When I'm dealing with large numbers like 100, 1,000, 10,000, 100,000, million, and it keeps going on and on and on, I write out these numbers and I end up with a whole host of zeros. They just keep going and going and going. But how do I know if I meant to write 1,000 or 10,000? It's just one zero. I could really easily get confused and mess up the entire problem. So what we do in math is a form called scientific notation. This helps you keep up with exactly how many zeros you meant to have after that one so that you don't get confused about what you were supposed to be multiplying and dividing. Scientific notation is fairly simple. You start with a base of 10, and then you raise 10 to an exponent that tells you how many total zeros comes after the 1. For instance, 10 to the second is 100 because there are 2 zeros after the 1. 10 to the third is the same thing as 1,000 because there's 3 zeros after the 1. 10 to the fourth works the same way, having 1, 2, 3, 4 zeros. This keeps going as long as you want it to go. You can have 10 to the 5th, 10 to the 6th, 10 to the 7th, 10 to the 11th, 10 to the 13th. Ever how many zeros the number has, that's how many zeros are represented with the exponent right here. Let's take a large number like 49 million. And let's say, okay, well, if I was having to deal with 49 million, the last thing I want to do is write that many zeros over and over and over again during my problem. So what they've introduced is something called scientific notation. It's a way to write it without having all those zeros. Now, we just showed that scientific notation is expressing a number with a 10 raised to an exponent that tells you how many zeros are there. For instance, 49 million is the same as 49 times 1 million. 49 times 1 and 6 zeros. Now I just showed you that scientific notation is when you say, okay, if a number has a 1 and a million zeros, then you're going to write 10 and raise it to the millionth power. Now, 1 million has 6 zeros, so it's the same thing as 49 times 10 to the 6. 1, 2, 3, 4, 5, 6. This can be rewritten as 4.9 times 10 to the 7th. You're writing the same number, but you're putting it in scientific notation. The specific format where you have a number times 10 to an exponent is scientific notation. Please note that the first number, represented here by A, will always be less than 10 but more than 1. That's how you know where to put the decimal when you're moving them around. With these three numbers listed behind me, I'm going to show you what it means for scientific notation to tell you which way to move the decimal point. With 5,000, as with any whole number, the decimal point comes after the last number. So for 5,000, it normally has a decimal point right there. So when you express it as scientific notation, or 5 times 1,000, which is 5 times 10 to the third, 5 times 10 to the third means take the number 5 and move its decimal place out 3 places to get the 5,000. So 5 normally has a decimal point here, but we've moved it out 1, 2, 3 places to get 5,000, which is the number scientific notation represents. You can apply that if you were given the scientific notation first and asked to express the number. You could say, well, I'm giving 4.5 times 10 to the second. Since multiplying by 10 to the second means to move the decimal place 2 spaces to the right, I'm going to look at my first number and say, well, where is the decimal point right now? It's in between the 4 and 5. So I need to move it to the right 2 places. That is 1, 2. I have to go past the 5 by 1 space, so I fill in that space with a 0. So it's 450. Now you'll notice in this case that the answer doesn't have 2 zeros. Even though it's 10 to the second, it doesn't have 2 zeros because you moved the space over 2 spaces. It's the same thing as 4.5 times 100. Since 100 has 2 zeros, your exponent is still 2. However, your answer of 450 will only have 1 zero. Let's try it one more time just so you don't get confused. 1.2005 times 10 to the 4th. 10 to the 4th represents 1,000. So you're multiplying this number by 1,000. I'm sorry, 10,000. You're multiplying this number by 10,000. But instead of writing out 1.2005 times 10,000 and working all of that out with the zeros and everything, you can look at this exponent and recognize, I need to move the decimal place to the right 4 spaces. So you find the decimal point in the first number and move it over 4. 1, 2, 3, 4. It goes right there and your answer becomes 12,005. Here's 2 homework problems to help you realize how to move the decimal point with scientific notation. You have 6 times 10 to the 5th. You're going to write the number 6 and then move its decimal place to the right 5 spaces. 1, 2, 3, 4, 5. Place your decimal point and fill in the empty spots with zeros. Then your number becomes 600,000. Number 2. You have 0.2 times 10 to the 8th. You start with 0.2 and move the decimal place to the right 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Place your decimal point and fill in the extra spaces with zeros. 1, 2, 3, 4, 5, 7, and you now have 20 million.
Never too late to make dessert with Jell-O.